Hello, am I audible?
Yes, sir.
Yes, sir.
So, in the last class, we discussed about the week one's content. Here we discussed that what is the basically we do in the digital system. Along with this, we discussed the VTC voltage transfer characteristics and the noise margin. Along with that, we also discussed that noise margin is very important if we are talking about conversion from analog to digital. Okay, noise margin is very important when we convert analog to digital signal. Why? Because in the digital scenario, we know that only two levels are exist. One is the zero level and second is the level one. Zero level basically represent the ground, whereas one level will be represent the VCC. Either it is a 5 volt, either it is a 10 volt, 15 volt, any that is the maximum voltage that we apply in the circuit that is called the logic one in the case of digital. But in the case of analog, all the voltage between 0 to 5 lies. All the voltages between 0 to 5 lies. So we have to set that when we are going to convert into the analog signal into digital, we have to decide that which voltage we are consider as a logic 0. Okay, we have a voltage range. Complete this voltage range. Okay, or we are taking any sinusoidal signal. So all the voltage range. Okay. Now in this scenario, we have to decide that below this, which voltage will be considered as a logic 0. Like I decide that this is the point where we are consider that it is a low level VL. Okay. Above this is the VH. Okay. Above this, all the voltage will be considered as a logic 1. Below this, all the voltage will be considered as a logic 0. But in between them, there are certain voltage will be available. This one. Okay, this is the certain voltage that is available between the VL and VH. Clear? So this is the difference between VH minus VL. Now this difference is different when we apply this signal into a circuit, digital circuit. Like I apply here. So VH and VL in this scenario is different, and VH and VL in this scenario is different. Okay, the difference between these two will be the noise factor added by this device. Okay, similarly, the difference between these two is the noise factor added by this device when we consider the logic low. Okay, and when we consider the logic high. Okay, so that's why we represent this one into the four different parameter. This is the input side, so I mentioned that VIH, input side VIL, output side VOH and VOL. Okay, so four parameters VIH, VOH, VIL and VOL. And that is the noise margin for this device. Noise margin for this device. Okay, any doubt?
Sir, if we apply VIH, then we should get Vivo L.
VIH, then we get the VOL. Yeah, because we are applying this particularly as a inverter. Okay, generally if you are talking about the weak one, so we are using this one as a inverter. So what is the inverter do? When we apply the logic 1, we are getting output as a logic 0. Okay, and when we apply the logic 0, we are getting the output as a logic 1. So 1 is the VIL. When we apply the input VIL, sorry, VIH, high input side, we are getting a VOL output side. Similarly, if we are getting the VI input side low, we are getting the VOH. And that's why the curve will be like that. This is the input side VI, and this is the output side VO. Okay. If input is low, like for example, I am saying this is the input is low. So we are considering when input is low, output is high, ideally. And when input is high, after that input is high, so we are getting the output is low. Okay, this is the ideal characteristics. Ideal characteristics. But practically, this is different because this is a electronic device. Okay, this will be created with the combination of either transistor or MOSFET. I am not sure that you are aware with the MOSFET, but it is a similar to the transistor, but used for the digital applications. Okay, so it will be taking some time. Like we apply the input, we are getting the output after a certain time. Okay, so this is the ideal characteristic. This particularly transistor, basically NOT gate or inverter will be created with the help of transistors or MOSFET. This will be taking some time. Okay, so ideally the time, if they are taking the time, so that what is the meaning of that one? My input output will be start reducing from this point and it will be 0 after this point, like that one. Okay, so this is the basically transition. Okay, and that you study in particularly week 1. This is the practical characteristics of inverter. Okay,
Okay, sir.
now similarly if we are talking about the that is a practical assignment if you are taking, if we consider that this is one buffer NOT gate, okay, we are saying the VIH is 4.2, VOH is 4.6, VIL is 1.2, and VOL is 0.6. Okay, so we calculate the noise margin. So there are two noise margin, NMH, that is for high level, and second is the NML, low level. Okay, so we already discussed that VOH is greater than VIH, then it is greater than VIL, then it is greater than VOL. Okay, so noise margin high is nothing but the difference between VOL and VIL, VOH and VIH. Similarly, noise margin low is VIL minus VOL. So if we calculate, so VOH is 4.6 minus 4.2 is 0.4. Then VIL and VOL 1.2 minus 0.6 is 0.6. If we calculate the overall noise margin, so overall noise margin is nothing but maximum value of NMH and NML. Okay, so that is 0.6 overall noise margin. This is the one type of questions on the VTC characteristics. If you are talking the second type of question, so like two inverter are connected in cascade. Okay, so it is a VIH1, VIL1, then VOH1, VOL1, then VIH2, VIL2, VOH2, and VOL2. Okay, so in that scenario, the noise margin high is basically the noise that will be added in this point. Okay, so that is VOH1 minus VIH2. And similarly, noise margin low is VIL2 minus VOL1. Okay,
So can you explain this?
explain this one.
Yes, how VOH1 minus V1.
Okay, basically the thing is that let me check. Okay, so basically thing is that if I say that these two particular inverter are identical, okay, if these two inverters are identical, so basically if these two inverters are identical, so I can say the VOH2 should be equal to VIH2, sorry, uh, VOH1, because the output we are getting here, that is same. Okay. Similarly, the output for low level we are getting here is also same. VOL2 should be equal to VOL1, and similarly VIH1 should be equal to VIH2, and VIL1 is equal to VIL2. Is it clear? Any doubt?
So isn't it VOH1 should be equals to V1H2 because that will be the input for the second inverter?
No, actually, the thing is that right now what I should consider that if these two particularly operation amplifier are identical. Okay, so if I break this operation amplifier, so the parameter of VIH and VIH2 both are same because these are the two different inverters. Similarly, VIL1 and VIL2 is same. VOH1 and VOH2 should be same, and VOL and VOL2 should be same. Is it
Okay.
clear?
Yes, sir.
Yeah, it's
Now, where the particularly noise effect will be created in between these two?
Yes, sir.
If VOH1 is not equal to VIL, VIH2. Okay, that means VOH1, this voltage is not equal to this voltage. So basically, we can say the noise will be created. Otherwise, what happen? This is a simple wire, no voltage drop. That means the both voltage should be same. But if these voltages are not same, so we can say the noise will be created. Noise will be added. Similarly, for the low level, VOL1 is not equal to VIL2. Then the noise will be created. So how should I basically identify the noise margin? By differencing these two?
Why do? Yes, sir.
Is it fine?
Yes, sir.
Okay. So that's why we differentiate these two to calculate what is the noise effect that will be introduced in between these two operations, these two inverters. So this is the way if two particularly inverter are connected in a cascade.
Okay, sir.
So if the question is given,
sir.
yeah,
Yeah, if the two inverter is identical, then for the noise margin we will do this thing na VOH2 minus
yeah.
VIH1.
If these two are not identical, we are using the same method. Okay. The thing is that if these two are identical, okay, only the noise effect will be considerable in these 2 points. This one and this one. Here we are taking the VOH1 and here we are taking the VIH2. Okay. If these two are identical, so only the noise effect or noise margin we are taking as a VOH1 and VIH2. Okay. Now, if we are not taking the non-identical, then noise margin will be the effect of three parameters. One, the inverter 1 plus inverter 2 plus the difference between VOH1 and VIH2. Clear? Because of this one, because of this one, and because of this one. Clear? Any doubt?
No, sir.
Now, how we identify the inverter 1 and inverter 2 are identical, that particularly will be dependent on the spice parameter. So without these, we don't say that these particular two inverters are the identical. So generalized form, what we take, we are taking the difference between these two and consider that this is the main reason of noise margin. So that's why we consider the VOH1 and VIH2, and the difference between these two is the noise margin. High. Noise margin high. NMH. So NMH is VOH1 minus VIH2, and noise margin low is VOL 1 my sorry VIL 2 minus VOL 1. Okay, if two inverters are connected in a cascade. On the basis of this one, we already see the practice assignment 3, 4, 5, and 6. Okay, two particular inverters are connected in a cascade form. I just take one more example. In case 1, VOH for both will be the 4.7 volt. VOL is 0.8 volt. VIH is 4.1 volt, and VIL is 1.3 volt. Okay, and case 2, VOH1 is 4.6 volt. VOL 1 is 0.6 volt. VIH 1 is 4.2 volt. VIL 1 is 1.2 volt. VIH2 is 4.0 volt. VIL2 is 1.3 volt. VOH2 is 4.7 volt, and VOL2 is 0.7 volt. Okay. So in the case 1, NMH is VOH minus VIH, that is equal to 4.7 minus 4.1 volt, and NML is equal to VIL minus VOL. That is 1.3 minus 0.8, 0.5 volt, 0.6 volt. Okay. In the case 2, NMH is VOH1 minus VIH2. That is 4.6 minus 4.0, 0.6 volt. And NML is VIL2 minus VOL1. So VIL2 is 1.3 minus VOL1 is 0.6. That is 0.7. Okay, so overall noise margin is 0.6. And in this case, overall noise margin is 0.7. Clear? Any doubt?
No, sir.
Okay. Now, this type of question will be given in the form of waveform also. Like one waveform is given. We are given as a 0.5, 4.8, 0.7, 4.7, mm, 4.0, 0.8, 4.2, 0.6, 4.5, 0.4. Okay, and the question is given V in is considered as logic 0 if V out is greater than 4.7 and logic 1 when V out is less than 0.6. Okay, so first of all, what we do, we are check that V out is 4.7, that means this point. This point will be considered as a logic 0 and V out less than 4.6, sorry 0.6. This point, after that it will be considered as a logic 1. Logic 1 and logic 0. Clear? Any doubt? If you remember in the graph here, so VH is the minimum level. VH is the minimum level and VL is the maximum level. So this is the 4.7. After that, V out is, after that values of the V out, always the V in is 0. So this is the minimum level, that 4.7. This is the minimum level. After that, all the value of V out, it will be considered as a logic 0. So that's why I consider that this particularly point is V input at low level and output at high level. Any doubt? And this one is the maximum level. After that, less than value of 0.6, all value are less than. So this is the maximum level. This is the maximum level. So we denote this one as a VOL and VIH. Okay. So from this curve and this particularly representation, we define that VIL is 0.7, VO, sorry, this one is VIH and VOL. Initially defined as the input x-axis, then after that we define the output y-axis. Okay, so VIL 0.7, VOL 0.6, then VIH 4.2 and VOH 4.7. Okay, now easily you can calculate the noise margin high, that is VOH minus VIH 0.5 volt, and noise margin low is VIL minus VOL, that is 0.1 volt. So overall noise margin is 0.5 volt. Okay.
Okay, sir.
Now, if you have any doubt, you can ask me the questions.
Sir, I had a doubt regarding one of the questions of the graded assignment. It's the loop inverter which is fed back its output.
Okay, wait a minute. Graded assignment.
Yes, sir. I don't want to answer, but how should we approach that? Because I've got a couple of different things when I tried to search for it on the net.
Wait a minute. Wait a minute. I just check it. Can you tell me the question number?
Yes, sir. 1 second. I'll just open it over here. Sir, it's question number 9.
Question number 9. Okay. Yes. So what will be the issue in that?
Sir, let's say, like if we approach it like this, we say that the the first in the first instance uh, the input is low, then
Mm-hmm.
the output will be high.
Mm-hmm.
And again, then what we do is we again feed that output high to the input.
Hmm.
So will this then once the input is high, then the output will again go low. So this will continue. So is it going to oscillate between high and low? Because what I found is that depending upon the way the inverter is built, if it is a like what I found is that they say that if it is a TTL based inverter or if it is a CMOS based inverter, the behavior is different. So that's what I wanted to check. Like, how should we approach this particular thing?
So the question number 9.
So, like, what we have been asked is that what is the voltage at the output? Now, if we say that if it is oscillating, then we'll not have a particular voltage at the output. But then the question asks that what is the voltage at the output? So, does it settle? Does it keep on oscillating? Like, I'm not sure like how to approach this.
Wait a minute. Question number 9. So this is the 5 and 0. Basically, your output will be fluctuating in
Okay,
that
sir.
scenario.
Okay, sir.
Okay, so you have to take the, I think the average value. Average value you have to take.
Okay. Okay, sir. So between 5 and 0, it's going to fluctuate.
Yeah, because it is a loop now.
Right, sir.
Till now, the input is not clearly defined that it is a completely 0 or completely 1.
Right,
So
sir.
we can't say that what is the output. So it is a fluctuating output.
Okay, sir. So, and since this is like the 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 VTC shown is not an ideal one. So let's say if input is 0, and then the output should be 5. But since it's not an ideal thing, then there will be some amount of loss, right? Is there some amount of loss when we have output, or is it going to be 5 volt?
No, it is going to be because VTC is showing till like for example till the voltage you applied that 1.8 volt, it will be the 5.
Okay. Okay.
Okay, and till when you apply the 3.2 voltage, it will be going to 0.
0. Okay. Okay, sir. Okay, sir. So it's going to fluctuate. So we need to take an average
Average
in
value
this.
of that. Yeah.
Okay, sir. Okay, sir. Thank you so much.
Average for a single cycle you can take. Okay.
Okay.
Any other doubts?
Hello. Yes,
Yes.
sir.
Yes.
Sir, practice assignment question number 7, sir.
Practice assignment question number 7. Let me check. Yes. Consider. So image. Yeah. So the question number 7 graph is this one. Okay. Now what they are asking? They ask the when the input voltage is 0.38. I think so. Yeah. When the input voltage is 0.38. So you know that at 0.35 it is a 0.9. If V in is 0.39, V out is 0.9. V out is 0.9 and V in is 0.47, V out is 0. Can you draw in between them? This is the straight line. Can you draw the equation for the straight line? Y is equal to mx plus c. Okay. Or basically what you have to
Yes,
do,
sir.
you have to calculate the slope of this one. So y2 minus y1 upon x2 minus x1. So what is the slope of this one is 0.9 minus 0 upon 0.47 minus 0.35. So it is a 0.9, sorry, 0.35 minus 0.47. 0.35 minus 0.47. It is a 0.9 divided by minus 0.12. So minus 7.5 is the slope. Okay. Now you have to
Yes, sir.
calculate the value of 0.38 here. So you know the x value is 0.38. You know you calculate the y value. So again you equate this one. So y2 You consider the y minus y1 0.9 divided by 0.38 minus 0.35, that is equal to minus 7.5. So y minus 0.9 is equal to minus 7.5 multiplied by 0.03, and y is equal to 0.9 minus 7.5 multiplied by 0.03. You can calculate easily. 7.5 multiplied by 0.03 minus 0.9. So the value is 0.675. So the answer is 0.675. Clear?
Yes, sir.
Sir, can you go for question number 5 once in practice assignment?
Question number 5. Okay.
Yeah.
This type question we already solved now.
I'm actually asking that there is only inverter working, right?
Basically, the thing is that in the question
So
number 5,
the
wait a minute. I just brief you about the question number 5. In question number 5, hmm, okay, so in question number 5, inverter 1 has a parameter VIL1 is 0.33, VIH1 is 0.38, VOL1 is equal to 0.18, and VOH is 0.65. Okay, and inverter 2 has the same parameter as a question number 3. So VIL2 is 0.35, VIH2 is 0.39, VOL2 is 0.13, and VOH2 is 0.68. Now noise margin high is what? Inverter 2 input parameter and inverter 1 output parameter. So VOH1 minus VIH2, because output high parameter is greater than input low parameter, input high parameter. So that's why we are considering the output of first inverter and input of second inverter. Okay, and NML is VIL2 minus VOL1. Okay, now put these values. So VOH1 is 0.65 and VIH2 is 0.39. Okay, and VIL2 is 0.35 and VOL1 is 0.18. Okay, so noise margin high is 0.26 and noise margin low is 0.17. Okay. Similarly, if you are talking about the only the question number 3 and 4, so in the 3 and 4, both particularly inverter has the same parameter. So there is no VI. This sorry, this is correct. There is no this one. Okay. So now noise margin I is VOH minus VIH. So 0.68 minus 0.39. That is 0.29 volt. And noise margin low is 0.35 minus 0.13. That is 0.22 volts. Okay. So that is the question number 5 and question number 6, and that is for question number 3 and question. Now any doubt? Yes, now any doubt?
No, sir.
If any other doubt related to the week one, you can ask. Okay. The deadline of week one is 25th, na?
Yes. Yes, sir. 21st it is given, sir.
Okay, 21st. Remember that you have to submit your handwritten solutions for the graded assignment. If you are not submitted your graded assignment solution, handwritten solution, then your marks, particularly for this assignment, will be considered as a 0. Books, if you want to refer that, there is one digital system books, Morris Mano. Digital Logic by Morris Mano. That is a good book. Except this, you can recommend any of the digital books. There are lots of books are available. Okay, if we want to study through the, if you want the PDF of that book, you can drop a mail or basically tell me. So I will share the PDF of that book. So I just want to confirm that is it easily understandable, na? Week one content that I explain you, that is easily understandable, or any doubt, any difficulties you are facing, or basically the thing that you want in a different way, so just tell me. I just stop this one streaming.